synchronization problems. In this tutorial, we will discuss about various classic problems of synchronization. Sophomore can be used in other synchronization problems besides mutual exclusion. Below are some of the classical problems depicting flaws of process synchronization in systems where cooperating processes are present. We will discuss the following three problems. Number 1, bounded buffer or producer-consumer problem. Number 2, dining philosopher's problem. And number 3, the last problem is the readers-writers problem. This problem is also called producers and consumers problem. A finite supply of containers is available. I am the producer. I take an empty container and fill it with a product.
I am the consumer. I take the full container, consume the product, and leave it empty.
Producer produces items one by one and places them in a buffer. The buffer can hold a limited, predetermined number of items. The consumer takes items from this buffer one by one and consumes them. The complex version of this problem is that there could be multiple producers and multiple consumers. Both the producer and consumer are in fact the processes or threads. For example, the producer thread generates some frames or web pages. The consumer thread shows them on screen or sends them via a network. The buffer that they use to exchange these data items is in fact a shared memory that can hold a certain number of items. The producer made a new item, but there is no place in the buffer. The producer must pause and wait until an empty space appears in the buffer. In the case of the consumer, he needs an item to proceed, but the buffer is empty. The consumer must pause and wait until the producer puts an item in the buffer. Real-world application of producer-consumer problem. First is the web servering architecture, content or server thread, and consumer or browser thread. Second is streaming audio or video, network and display thread, communicate through a shared buffer.
Hello mga kaplatek! Today I will talk about dining philosopher's problem. And here's our problem. We have 5 philosophers in our scenario, and 5 utensils as well. How will the 5 philosopher can eat the noodles simultaneously? Remember, a philosopher may eat if he can pick up the 2 forks adjacent to him.
First utensil the philosopher will pick up is the one on his or her left side, then on the right side. When finished, the first one the philosopher will put down the right utensil he's holding on, then followed by the left utensil. The picking of utensils is one at a time. The philosophers must have unavailable utensils both left and right to be able to start eating. They are not able to start eating if there is only one utensil available in their side.
The real-world application of dining philosophers problem. Dining philosophers cooperating processes that needs to share limited resources. A set of processes that requires access to multiple resources at the same time including file and printer. Online course scheduling. User account cost database timetable of classes.
If one notebook exists where writers may write information to, only one writer may write at a time. Confusion may arise if a reader is trying to read at the same time as a writer is writing. Since readers only look at the data but do not modify the data, we can allow more than one reader to read at the same time. The main complexity with these problems stems from allowing more than one reader to access the data at the same time. A data problem such as a file is shared among several processes. Each process classified either a reader or a writer. Multiple readers may access the file simultaneously. A reader has exclusive access in which he cannot share with either a reader or another writer. A solution gives priority to either readers or writers. Reader's priority. No reader is kept waiting unless a writer has already obtained permission to access the database. Writer's priority. If a writer is waiting to access the database, no new reader can start reading. A solution to either version may cause starvation. In the reader's priority version, writers may starve. In the writer's priority version, readers may starve. And here is a semaphore solution to the reader's priority version without addressing starvation. Real-world application to reader-writer's problem is a message distribution system. We must keep track of how many messages are in the queue.
Uses of semaphores. Semaphores can be used for more than simply protecting a critical section. First, to protect access to a critical section. Example is the database in the reader-writer's problem. Second, as a murex lock. Example, to protect the shared variables used in solving a problem such as reader count in the reader-writer's problem. Third, to protect a relationship. Example is that empty and full as used in the producer-consumer problem. Fourth, to support atomicity. Example is you pick up either both chopsticks at the same time or neither, you cannot pick up just one. Fifth, to enforce an order on the interleaving of the statements in the processes.